Section 2.1, the addition property. The associative property of addition means you can change the grouping of add-ins and it will not change the sum. The algebraic definition is parenthesis a plus b close parenthesis plus c equals the same thing as a plus parenthesis b plus c close parenthesis. For example, if you have 6 and 7 being added together in parentheses with 3 later being added on the outside, you get a sum of 16. Likewise, if you have 6 on the outside, but 7 and 3 have been added together in parentheses, you will still get a result of 16. Solving equations using the addition property. When solving equations, the goal is to isolate the variable on one side of the equal sign and the number on the other side of the equal sign. This can be done in the following form. See below. Variable equals a number, or a number equals a variable. Now, however, since I am the instructor, I have a preferred method of doing this, and I pretty much do this all the time. I tend to go with the first format, meaning I like to have my variables on the left-hand side of the equal sign and my numbers on the right-hand side of the equal sign. However, it does not mean that you have to always do it the way that I do it. You may choose the second format. You may want to have your numbers on the left and your variable on the right. It does not matter as long as the arithmetic and operations are done correctly. We both should come up with the same solution. Note, to move a term to the opposite side of the equal sign, you must perform a sign change of that term on both sides of the equal sign so that the equation is balanced. Here are your first two examples. Solve w positive 6 equals 10. In order to get the w by itself on the left-hand side, which again is what I prefer to do, I need to move the 6. The way to move the 6 is to change its sign. Is a positive 6, so therefore to move it, make it negative, which means we're going to be subtracting 6 on both sides of the equal sign. By doing such, the 6's on the left cancel out, leaving you with the w by itself on the left, equaling a positive 10 being combined with the negative 6, which are unlike signs, so I'm going to subtract and keep the sign on the larger number, so w equals positive 4. Next example. I have a variable not only on the left, but also on the right. Once again, I'm choosing to move my variables to the left, so therefore I'm going to move the L, or also pronounced as 1L, to the left-hand side. So I'm going to subtract L, or 1L, from both sides of the equal sign, which means on the right-hand side, the L's will cross out, and I'm going to combine a positive 2L with the negative 1L, which are unlike signs, so therefore I'm going to subtract and keep the sign on the larger number, which will give me L, or 1L, negative 4 equals 10. Now, I've got my variable on the left. Now I want to move my last number to the right-hand side where the other one is. The 4 is negative, so to move it, I'm going to change its signs by adding 4 to both sides of the equal sign, which means the 4's cancel out, leaving the L on the left-hand side by itself, and a positive 10 combined with the positive 4 is a positive 14. So therefore, L equals 14. Two more examples. I'm going to follow the same process as I just did in the previous slide. In order to solve for z, I'm going to add 7 to both sides. The 7's on the left cancel, leaving the z on the left-hand side by itself. Positive 9 combined with positive 7 is a positive 16, so z equals 16. Here, I'm going to move my 2p to the left-hand side. The 2p is assumed to be positive, so if I want to move it, I need to subtract it, make it negative. 2p on both sides of the equal sign, which means on the right-hand side, they cancel out. 3p, which is positive, combined with 2p, which is negative, unlike signs, subtract and keep the sign of the larger number, will give me 1p or p. Positive 4 equals 19. Finally, to solve for p, I need to remove the 4. It is a positive, so to remove it, I need to subtract 4 from both sides of the equal sign. The 4's will cancel out on the left, leaving the p by itself, and a positive 19 combined with the negative 4, which are unlike signs. I'm going to subtract and keep the sign of the larger number, will give me p equals positive 15. Now, solving equations that contain fractions. My preferred method is removing the fractions, and therefore to do such, we will use a method called the least common denominator. Okay, in this case, we have two denominators here, which is the number 2 and the number 4, and the least common denominator is the smallest number that all denominators divide into evenly. In this case, 4 is the smallest number that both 2 and 4 divide into evenly. So what's going to happen here is I'm going to multiply every one of those three terms individually by 4. So I'm going to do 4 times x, bring my negative sign down, 4 times 1 over 2 equals 4 times 3 over 4. This is what's called the write down step. Now after you write it down, go back and perform the actual operations. 4 times x is 4x. Now I'm going to do something that's called cross reduction here, because I recognize that the denominator of 2 actually can go into 4. Well, 2 goes into itself one time, but goes into 4 twice. So now you have 2 times 1, which is 2. No more fraction. That's been removed. Equals, on the right hand side, you may notice that the 4's basically cancel out, leaving you with just 3. So all fractions have been removed. It's a normal equation now. So I begin solving for x by first moving the 2. It is a negative 2, so add 2 to both sides of the equal sign. The 2's on the left hand side cancel. So I'm left with 4x equals a positive 3, combined with positive 2, which equals a positive 5. Now, in order to get the x by itself, I need to remove the 4. The quickest way and the best way to do this is to divide both sides by 4. Okay? So I'm going to divide the 4 by 4, and on the right hand side, divide the 5 by 4. So on the left hand side, the 4's basically cancel out or become 1. Now 4 doesn't divide into 5. Therefore, we will leave it as a fraction. So therefore, x is equal to 5 over 4 times b plus a times c. In this case, for example, 2 times a and 2 times 3. First step, we're going to apply the distributive property here. If you notice, there is a 5 on the outside of that parenthesis. So therefore, everything on the inside of there will be multiplied by 5. So we're going to do 5 times 3x and do 5 times negative 1. 5 times 3x, negative 5 times 1. Bring your positive 2 down equals the right-hand side. Now when you do the actual multiplication, 5 times 3x is 15x, negative 5 times 1 is 5. Bring your plus 2 down, positive 2, equals your right-hand side. Now, on the left-hand side, we have like terms. The like terms I speak of are the negative 5 and the positive 2, which we will go ahead and combine those two together before we proceed to anything else. So negative 5 and positive 2 are unlike signs. I'm going to subtract and keep the sign of the larger number. That will give me a negative 3. So my next line should read as 15x, negative 3 equals the right-hand side. Now I begin to move the 12x. The 12x is assumed to be positive, so I'm going to subtract 12 on both sides of the equal sign, subtract 12x, should I say, on both sides of the equal sign. The 12s on the right hand side cancel. Positive 15x combined with negative 12x, unlike signs, subtract, keep the sign of the larger number. That will give me a positive 3x. Bring my negative 3 down, equals 6. Now, I'm going to move the negative 3 to the right hand side of the equal sign by adding 3 to both sides. The 3's on the left hand side cancel. 3x equals 6 combined with a positive 3. Both numbers are positive. Add and keep the common sign. So 3x equals 9. Final step to solve for x, remove the 3 by dividing 3 on both sides. The 3's on the left hand side cancel or become 1. And 9 divided by 3 is a positive 3. Section 2.2, the multiplication and division property, which is going to be more of what we just finished doing in 2.1. The associative property of multiplication basically says it doesn't matter how you multiply numbers. If you multiply them correctly, you will still come up with the same result. So solving equations using the multiplication/division property. When solving equations, the goal is to isolate the variable on one side of the equal sign and the number on the other side of the equal sign. In the following examples, we'll be doing this by using the multiplication, LCD, or division property. Note, to solve for a variable, you must remove the coefficient from the variable. To do this, we must perform the opposite of multiplication, which is division, on both sides of the equal sign so that the equation is balanced, as we've been doing. Solve 3q equals negative 18. In order to get the q by itself, I need to remove the 3. The only way to do this is to use the division property, which basically says to divide both sides by 3. The 3's on the left hand side cancel, leaving the q by itself, and a negative 18 divided by a positive 3 is a negative 6. So q equals negative 6. Solve 2y equals 10. Once again, to solve for the y, I need to divide both sides by 2 using the division property. If I divide both sides by 2, the left-hand side, the 2's cancel, leaving the y by itself, and 10 divided by 2, both numbers being positive, equals a positive 5. So y equals 5. Solve p over 3 equals 5. Here we have a denominator. We will use the least common denominator method. Here, 3 being the only denominator, therefore every term will be multiplied by 3. So that's going to be 3 times p over 3 equals 3 times 5. That is the write down step. Now after you write it down, go back and perform the actual multiplication. If you notice on the left hand side, the 3's cancel out, leaving the p by itself on the left. And if you come to the right hand side, positive 3 times positive 5 equals positive 15. So p equals 15. Solve t over 6 equals 8. Same principle here. We will use the LCD method. In this case, the LCD is 6 because it's the only denominator here. So both sides of the equal sign is multiplied by 6. Once again, on the left-hand side, you notice that the 6's cancels out, leaving the t by itself. On the right-hand side, you have a positive 6 divided by a positive 8, which will give you positive 48. So t equals 48. Section 2.3, further solving of linear equations. Solving linear equations. Solving linear equations is not difficult. We visited this subject in the recent sections. However, we will revisit them again in combination with what we've learned in sections 2.1 and 2.2. See examples on the next slide. Note, remember to check your answer to verify if it is a true solution. First things first is to use the distributive property, which means everything on the inside of the parentheses we multiply by 2. 2 times 2x. Bring your positive sign down. 2 times 1. Bring your positive 2 down that was already there, equals the right-hand side. That is the write-down step. Second step, after you wrote it down, do the actual multiplication. 2 times 2x is 4x. Bring your positive sign down. 2 times 1 is 2. Right now your positive 2 that was already there equals your right-hand side. On your left-hand side, you do have like terms, which is the positive 2 and the positive 2, same signs. Add and keep the common sign. So 4x positive 4 equals the right-hand side. Begin solving for x by subtracting 3x from both sides because the 3x is assumed to be positive, so make it negative. On the right-hand side, they cancel out. Positive 4x combined with negative 3x is 1x, or x. Bring down your positive 4 equals 6. In order to solve for x, subtract 4 on both sides of the equal sign because the 4 is positive. Make it negative to move it to the right-hand side. Therefore, on the left-hand side, they cancel, leaving the x by itself, and therefore a positive 6 combined with the negative 4 will give you positive 2 because of the unlike signs. Subtract and keep the sign of the larger number. Therefore, x equals 2. Solving equations containing fractions using the least common denominator method. We've revisited this in the previous slides, and we'll do it again here. The least common denominator here is 2 because it's the only denominator, so every one of these terms is individually multiplied by 2. As such, 2 times 5 over 2x, negative 2 times 1 equals 2 times 3 over 2x, negative 2 times 4. That is the write down step. After you wrote that down, go back and do the actual multiplication. As you can see, the 2's on the first term cancel out, leaving you with 5x. And the 2's on the second fraction cancel out as well, leaving you with 3x. So what you have now is 5x, 2 times 1 being 2, equals 3x, and 2 times 4 being 8. Now you can begin solving for the variable. So I'm going to move the 3x by subtracting 3x on both sides of the equal sign. So therefore they cancel out on the right. Coming to the left-hand side, combining the negative 3 with the positive 5, which is a positive 2x. Unlike signs, bringing out my negative 2 equals my negative 8. I'm going to add 2 to both sides. The 2's on the left-hand side cancel. 2x equals negative 6 because we have unlike signs on the right-hand side. Therefore, we subtract and keep the sign of the larger number. So 2x equals negative 6. Final step. Divide both sides by 2 on both sides using the division property. The 2's on the left-hand side cancel. Therefore, x is left by itself, and negative 6 divided by 2 is a negative 3. Solving equations containing decimals. Removing the decimals, basically. Okay. To remove decimals, you observe the decimals within the problem, and you count the number of decimal places within each decimal. If they all have the same amount of decimal places within the decimal, then therefore every decimal will be moved that many of times. As you can see, 0.6, 0.06 should I say, and 0.10 and 0.16 all have 2 decimal places behind the decimal, which means each one of those decimal numbers will be moved to the right twice. So if you do so, rewriting the problem gives you 6x, negative 10 times parenthesis x, negative 2 close parenthesis, equals negative 16. Now we apply the distributive properties, which means I want to multiply everything in the parentheses by negative 10. So now I'm going to have 6x, negative 10 times x, negative 10 times negative 2 equals negative 16. That is the write down step. Do the actual multiplication next. So I'm going to have 6x, negative 10x, negative 10 times negative 2 is positive 20 equals negative 16. We have like terms on the left-hand side, which is combining 6x, which is negative 10x, which is unlike signs. So therefore, we subtract and keep the sign of the larger number. We get negative 4x. Bring down your positive 20 equals your negative 16. Subtract 20 on both sides of the equal sign. The 20's cancel on the left, leaving you with negative 4x by itself on the left. Negative 16 and negative 20 are the same signs, so therefore add and keep the common sign. So negative 4x equals negative 36. Final step, divide both sides by negative 4. The 4's on the left-hand side canceled out. Negative 36 divided by negative 4 is a positive 9. Therefore, x equals 9. Solving an identity equation. Sometimes when solving equations, you may find the left-hand side equals the right-hand side and vice versa. When this occurs, the equation is known as an identity. This means that all or every real number is a solution to both sides of the equation. I will not make you responsible for knowing this, so take a brief look at the example, try to understand it, and see what I was referring to in the previous slide. Section 2.4, further problem solving. Solving direct translating problems. Sometimes you'll be given an algebraic sentence and be asked to translate it into an algebraic expression and solve it at the same time. This is not too terribly difficult. However, you must be careful of what you are reading and how you translate the meaning of the certain keywords. See the next slide. Example, 3 times the number minus 6 is the same as 2 times the number plus 6. Find the number. 3 times the number translates to mean 3 times x. Minus 6 translates to mean negative 6. Is the same as means equal. 2 times the number means 2 times x. Plus 6 means positive 6. So what is your equation? It's going to be written out as 3x negative 6 equals 2x positive 6. Here you have an equation, and now you can solve for x. I'm going to move the variable from right to left, so I'm going to subtract 2x from both sides. The right side, the 2x's cancel. Combining the 3x with the negative 2x on the left gives me 1x or x, however you want to say it. Bring your negative 6 down, equals 6. Finally, to solve for x, add 6 to both sides. The 6's cancel on the left, leaving the x by itself, and positive 6 combined with positive 6 is positive 12. Therefore, x equals 12. Solving problems involving relationships among unknown quantities. This is more of solving for a word problem by translating algebraic words into an algebraic expression. See the example on the next slide. An 18-foot wire is to be cut so that the length of the longer piece is 5 times the length of the shorter piece. Find the length of each piece. What do we know? 1, the total length of the wire is 18 feet. That is in the reading. 2, the length of the longer piece is 5 times the length of the shorter piece. That needs to be translated into an algebraic expression. Translation. We don't know what the shorter piece is, so we'll call that x. The length of the longer piece is, we'll call it L. Now, 5 times the length of the shorter translates to mean 5 times x. So here's a recap of what we know, and here's a recap of what we just translated. So what would be our equation here? Well, there's no already pre-established formula, but we can make up one. We have a short piece and a long piece, and we know it has to equal the total length of the wire. So therefore, a quick formula you could have here is short piece plus long piece equals total length. So the short piece we said would be called by x. The longer piece we translated to mean temporarily 5x equals the total length of the wire, which is 18. Here's our equation. We have like terms on the left-hand side, which is x or 1x, being combined with the positive 5x, which is 6x equals 18. To solve for x, divide both sides by 6. Therefore, x equals 18 divided by 6, both numbers being positive, gives me a positive 3. So x equals 3. Since the short piece is represented by x, then the shorter piece equals 3 feet. And also, since the longer piece is represented by 5x, so the longer piece is 5x, which equals 5 times 3, which equals 15. Or you could have easily just subtracted 3 from 18 and still got 15 feet as well.